In this video, I want to show you how we can derive triple angle formulas for sine and cosine. Let us start with cosine. Cosine of 3x is equal to 4 cosine to the 3x minus 3 cosine x. We want to prove this formula for cosine. To do this, let me remind you this sum formula for cosine. Cosine of alpha plus beta, which alpha and beta are two angles, is equal to cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. We need to use this formula to prove cosine of 3x is equal to 4 cosine to the 3x minus 3 cosine x. Now, let's suppose angle alpha in this relation 2x and angle beta x. Then, by using this relation, cosine of 2x plus x equals cosine of 2x, cosine of x, minus sine of 2x sine x. Attention, we want to prove that this equals to this expression. So we have to try to write sines in terms of cosine, and we have to try to write this double angle in terms of x. If we want to write cosine of 2x in terms of cosine of x. Remember from double angle identities, if you remember from double angle identities, cosine of 2x is 2 cosine squared x minus 1 times cosine of x. And again, if you remember from double angle identities for sine, sine of 2x is 2 sine of x cosine of x times by sine of x. Multiply cosine of x in the bracket, then you have 2 cosine to the 3x minus cosine of x minus 2 sine squared x cosine x. If you multiply sine in the bracket, we have 2 sine to the 2x cosine x. Again, don't forget, we want to prove that this equals to this. As you can see here, we have only cosine. So, this is a formula for cosine of 3x. But we want to get to this formula. So we have to try to get rid of this sine to the 2. From Pythagorean identities, if you remember, sine to the 2 is 1 minus cosine to the 2x. This is a relation between sine to the 2 and cosine to the 2. We can replace sine to the 2x with 1 minus cosine to the 2x. So, if we do this substitution, we can get to our answer. 2 cosine to the 3x minus cosine x minus 2 times 1 minus cosine to the 2x times y cosine x. Now let's multiply the 2 in the bracket, and at the same time let's multiply cosine x in the bracket. So basically we want to multiply 2 cosine x in the bracket. By doing that, we have 2 cosine to the 3x minus cosine x minus 2 cosine x plus 2 cosine to the 3x. So we multiply negative 2 in the bracket and we multiply cosine x in the bracket, and we got this expression. Now let's simplify this. We have a 2 cosine to the 3 and a 2 cosine to the 3 at the end. In total we have 4 cosine to the 3x minus cosine x minus 2 cosine x is minus 3 cosine x. So we have proved that cosine of 3x, this is cosine of 3x, is equal to this. And this completes our proof for cosine. Now we want to prove a similar identity for sine. And attention, there are different ways for proving these triple angle formulas. Another method is based on the complex numbers, but here our focus is using a method based on trigonometric identities and relations that we have learned before. But there are other ways for proving these identities. Here, similar to the previous example, we use this relation. Sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. This is the sum formula for sine. To prove that sine of 3x is equal to this, we write 3x in the form of 2x plus x. So alpha is 2x, beta is x. If we use this formula and we expand this equals sine of 2x, cosine of x, plus cosine of 2x sine of x. Always when you want to prove an identity, a relation, you have to have an I on the other side. Look at the other side. We want to get to this, and here we have only sine. So we have to try to get rid of this cosine and this cosine of 2x. And also, we have to write this sine of 2x in terms of sine of x and cosine of x, because we don't want to have in the other side sine of 2x. We want to have only x. So, if we use double angle identity for sine of 2x, based on the double angle identity, sine of 2x is 2 sine of x cosine x. Multiplied by the cosine x that we are here we have. So we substitute sine of 2x with 2 sine x cosine x. This is the identity that we know for double angle identities. From double angle identities. Cosine of 2x. If you remember, cosine of 2x, for cosine of 2x, we have different formulas. Cosine to the 2 minus sine to the 2. 2 cosine to the 2 minus 1. And 1 minus 2 sine to the 2. But which one is better to be used here? Because we want to write in terms of sine, this one is the better one to be used for this. So we substitute cosine of 2x with 1 minus 2 sine to the 2x times by sine of x. So we substitute this with this from double angle identities. Now let's simplify this expression. We have 2 sine x, cosine times cosine would be cosine to the 2x. If you multiply sine x in the bracket, we have sine x minus 2 sine to the 3x. We multiply sine x in the bracket and we have this. Now look at this. This is the only thing that we have to get rid of. Cosine to the 2 is 1 minus sine to the 2 from Pythagorean identities. So this equals 2 sine x times 1 minus sine to the 2x plus sine x minus 2 sine to the 3x. If you multiply 2 sine in the bracket, we have 2 sine x minus 2 sine to the 3x plus sine x minus 2 sine to the 3x. Add similar terms to each other. 2 sine x plus sine x is 3 sine x. And minus 2 sine to the 3 minus 2 sine to the 3 is minus 4 sine to the 3x. And this completes the proof for sine. So in this video we proved triple angle identities or triple angle formulas for sine and cosine.